Three, two, one. All right, everyone. Welcome to another episode of the Some Engineering Podcast. Today we have Alex Chantavy from Lyft, where Alex is a software engineer. And Alex and I are going to talk about a tool, an open source tool that was developed in-house at Lyft, and it's called Cartography. And Cartography is a Python-based tool that consolidates infrastructure assets. And one of the major use cases at Lyft is security. But I'm going to let Alex talk about that. Alex, welcome. Thank you so much. I'm very excited about this episode. So over to you. I'll start. What is Cartography? What do you guys do with Lyft? At Lyft?
Oh, thank you very much for having me, Lars. Cartography is, like you said, it's a Python tool that grabs infrastructure assets from multiple sources and it aggregates it in a knowledge graph. And the advantage of being able to do that is you're able to make all these connections that would have otherwise been very difficult to see if you were looking at it solely through a table. And having things be in a graph is very flexible. You can kind of slice and dice that data any way that you might want to. And the main key scenario, well, one killer app that we use it for is something that I blogged on recently, is for container vulnerability management. But before I get too far into that, though, and into the weeds there, the original problem that Cartography was set out to solve was around offensive security scenarios. So backing up even a little bit further, I'll just be the first one to say Cartography was not my idea. It was the idea of my mentor, Sasha Faust. And the original thing was, well, if we are red teamers, if we are looking at a particular environment, trying to identify targets, then there's that whole saying about how an attacker is going to think in terms of a graph, not in terms of a list. And then so they'll be looking for different ways to access these valuable assets. How can they get a map of the environment and find their way to target? And it just made sense to put all of that aggregated in a graph database. So you have your sort of, if you like Harry Potter, your sort of Marauder's map. How do I get to what I need to go? Mm-hmm. And so from that perspective, we found that iterating on that, you can build automation on top of that. Defenders find it very useful because you can see, oh, this is how an attacker might look at my assets, might look at my particular environment. And as a defender, it's also really interesting because now you can create a very specialized sort of self-maintaining map, a self-maintaining inventory, and then you can slice and dice that to create those tables, because sometimes viewing it in a graph might not be the most intuitive thing or useful thing for a specific scenario. If you just want to give me a list of all the compute instances all across my AWS accounts, well, you don't really need a picture for that. It's kind of neat and helpful, but sometimes you just want a spreadsheet, and then Cartography can go and do that for you. Mm-hmm. There are a number of it's so interesting seeing this tool evolve from something that was offensive focused to using it for scenarios that are more defensive focused, and also for infra focused. So at Lyft, one of the key applications we use it for is container vulnerability management, where we use it to deliver very specific actionable insights. So one of the key things that we wanted to do was we run Kubernetes at Lyft. So there's about 1,000 different services that we have, mm-hmm. and they all are built from a set of base images. And then so if you are going to, if you want to, we wanted to continually report on what are the vulnerabilities that affect a given service. And we also wanted to make sure that was that these asks that we sent to the service teams was as actionable as possible. Mm-hmm. So let's say that I have the payment service, and I have my payment service, and then I scan the payment service. I get back a big list of vulnerabilities. Now, I could just take every single one of those CVEs and then send it to that service team and call it a day. Be like, oh, I'm done as a security team. Well, that's not really acceptable, because if anyone who's really worked with that before, you'll find that you scan that image, and then a lot of time your scanner may find 100 different CVEs on there. some of which may or may not actually tell you that, oh, it has a fixed version or not a fixed version. But the main technical roadblock here is you'll find all those problems, but you won't know as the service owner of the payment service, how do I actually fix them? In most of those cases, to fix those vulns, they would have been introduced by a parent image and not yourself. So you will need to wait for your parent image to update themselves and then consume that fix. Or in certain cases, maybe you introduced that vulnerability yourself to the payment service. Using a graph-based approach, we are able to build this dependency tree and then calculate, okay, these are the things that you yourself can actually fix. These are the other problems that you must wait on from your parent images to update themselves, and then cascade those changes down the entire dependency tree. And we built, so this problem lent itself really well to a graph shaped solution. And we were able to build automation on top of that that makes some reconciliation of, okay, well, we've done a follow-up scan on that image, and all of those problems that we previously scanned before, they're all gone. And then so now we can go back and close the tickets that were previously associated, that we previously filed. And so we kind of build this automated issue management system powered by a graph backend. And that's I'm going to be giving a little bit more of a talk later on at a B-side San Francisco, I think next month, going way more in depth on that. But there's a blog post on that too.
Fascinating. There's so much content in there, and I'm going to ask you, I always use the term double click some of these concepts. Now, this is a pretty nerdy podcast, but I think I feel like sometimes even it's always helpful for the audience if we maybe go back to explaining a few concepts. I'm trying to pull it up, but what's his name? David Heinemeier, like the whole thing about their migration back into on-premise, and he laid out in the blog post how, using Kubernetes, like you may have one pod, but here are all the additional adjacent or attached services. Can you maybe explain to the audience a little bit how the nested character of infrastructure and how that lends itself to capturing that information into a graph? Is that something you can elaborate on a little bit? Just the basics of how that stuff works?
I can wave my hands around and try.
That's great.
Thank you for reining me in. I will. I'm a little excited here to like nerd out and then talk about all these things in a ridiculous amount of detail as much as I can. But
this is the place to do it. This is the place to do it. This is the place to do it.
Perfect. I'll preface this by saying that I am not a Kubernetes or infra expert. So my understanding of how this all works, though, is so Kubernetes is basically orchestrated containers, right? So you want to run your containers in a whole bunch of microservices, and then you use images to do all of that. And as part of for efficiency, every service doesn't want to maintain every single aspect of their image. They don't want to say, oh, this is my Linux layer, this is the layer that goes on top of that, this is the layer. No, they want to, you want to delegate that to the work. I guess a large enough tech company will delegate that work to their infra team to manage those images and say, this is our approved Linux image that you should use. This is our approved Python image that you should use. And so that way it's just like, okay, well, that way your product teams and then don't need to worry so much about infra. They can just focus on application. And so where I was going into that earlier with my example of container issue management was we wanted to keep our app developers working on the app stuff, where if they get a vulnerability, they need to know exactly, okay, well, is this something that I can actually fix? Or is this something that infra needs to fix? And if it's something that infra needs to fix, don't send me that ticket. Send that to the proper owner.
Great. Later on, I think you have a little demo prepared as well, and we can see exactly how it works. Can we? What was and by the way, I love how you're so humble about how you're not the guy who invented it, but I mean it's very obvious from your blog post and how you talk about it, is that you're probably the main maintainer of cartography right now. There's probably no one who's got better knowledge about it than you, and is so. Can you talk a little bit about when when you guys started developing cartography in-house? What was the trigger? Like what was the why now, and what led you guys down a path of developing an in-house? I mean, clearly you have tons of skills at Lyft, right? But that doesn't mean you have to do it, right? There's plenty of other stuff you can work
Mhm.
on. So what was the genesis of cartography?
I think that at that time when we went open source with it, well, actually, I think we've been open source with cartography maybe just a little. We think we might have just passed our fourth anniversary of being open source, so that's really awesome. That's really exciting.
Yeah.
Um, I think that the main genesis of this was that at that time there wasn't really anything that did what cartography did. There
Mm-hmm.
were other similar graph-based security tools out there. The main one that comes to mind is something like Bloodhound, which is focused on Active Directory scenarios,
Mm-hmm.
and a very, very powerful tool, very powerful approach. And at the what we wanted to do though is that the main thing that cartography was trying to do was offer this sort of flexibility and offer this multiple data sources. How do you link those things together? And at that time, it wasn't really there. And then Sasha had done like a lot of experimentation, had a lot of experience and a lot of passion toward pursuing this. And then so it was, well, let's get this done. You know, this is something that we want to share and build a community out of. And then we've learned a lot from taking a project open source and then making a lot of friends along the way and seeing what works, what doesn't work in open source. And I think that that's been probably one of the biggest highlights of my own career.
Yeah, I mean, we just need to look at the GitHub stars here. It's super. I mean, cartography is super popular, and um, so can you walk us a little bit through the technical details of how cartography works, starting with the data sources, how you acquire data from those sources, essentially how you build your data pipeline, right? And then your
Mm.
backend, which I believe is Neo4j, the graph
Mm-hmm.
database, how you get it out, like the different queries I can write. Like walk us through that, how that works.
Sure. Yeah, so cartography in open source is designed to be as simple as possible, not requiring many different dependencies or anything like that. So it's simply just a Python CLI tool that you go and install with a pip install cartography. And the way that you would set it up is through a number of different config files. And essentially all that it does is it will talk to a number of APIs. So you can talk to your AWS API, your Okta API. It'll grab the data from there, and then it will load it to a graph database. And then the database that we chose is Neo4j. The main reason why we went with Neo4j is because we really liked the Cypher query language. It lets you sort of, I guess the way that I would put it is it lets you draw ASCII art and match paths based on that. And
Mm-hmm.
once you get past that initial hump, that learning curve, it's extremely expressive, and then you grow to like it. It's very polarizing though, but yeah. But
Oh yeah.
like essentially though, like that's the most simple setup where we wanted to keep this idea where anybody with a laptop or anybody with a laptop can just grab the tool and then like spin up a Neo4j database using like Docker or whatever you want, and then just like run the CLI tool. Boom, there you got it. You don't have to install any. It's not super opinionated about what infra you are going to run it on. And in some cases, this has sort of made future technical decisions slower, but at this trade-off of like having we made a conscious decision to try to like let the barrier for entry be as low as possible.
Hmm.
I guess like the example there is like we could have said that, oh, you must run this on an EC2 instance. You must put this with some very specific infra components, such as a like AWS SQS simple queue service. You must put this with like another other data platform type stuff. And you know, if we went that direction with like more involved infra, then we probably could get more powerful things like more real time refreshes and other things
Yeah,
like that. But you know, again, simplicity first for this purpose.
yeah. And in fact, I mean, yeah, real time. It's always the question. Everyone wants real time, but do you actually need it? How often, by default, how often do you collect data from the APIs? How often, by default, if I install cartography?
Ah, so if you by default, if you install Cartography, you just have the CLI, you hit enter. That's all it is. Cartography is very dumb in that sense.
Hmm.
It's up to the deployer to decide, do I want to put this as part of a cron job? Do I want to put this as part of an Airflow job? Do I want to make my own ETL with this? How do I want my deployment to look like? And there's a number of different
Mm.
considerations. Uh, in general, I would recommend simple is better. At Lyft, we've gone back and forth about, okay, well, we started off with a very what you call a very simple monolithic cron where just to do every single one of your data syncs one by one by one down a list, and then we ran that until it became too slow. And then after that, we decided, okay, well, now we need to split this up into multiple crons. And then we found, oh wait, now we're running into parallelization problems. Now we're having like some race condition issues, and so then we got to think about, okay, well, uh, if as long as we ensure the property that one resource is synced at any given time, then we can let everything be parallel, and then we can get some good speed. And then the next step, the next progression after that would be to migrate to something more powerful or more involved like Airflow. But it's iterative baby steps. What point there's many different ways to deploy cartography is my point.
Got it. Yeah. Flexibility. Yeah. I mean, what you just said sounds a lot like sounds like there's a lot of overlap with the analytics engineering ecosystem, right? With the data ecosystem, like I mean, you mentioned ETL, we said Airflow, orchestration, and it sounds. I mean, that to me always sounds like the concept behind it is basically data acquisition, right? Like the value
Right.
is getting clean data about the state of your infrastructure. Um, what was your original source? It's AWS, right? Lyft runs on AWS, I believe.
Yes,
Right.
and well, there's like there's at least a dozen different plugins on there. Like we have Okta, we have GCP, we have G Suite, we have a number of different sources in cartography, and then I
Mm-hmm.
guess um, the main thing that I would say is the advantage is that not that we have more coverage of any individual source, but the fact that you can draw relations from one to the other. So to assume an AWS role because of a trust relationship. And so
Mm-hmm.
this cross platform dependencies, those become very interesting.
Mm-hmm. Mm-hmm. And so, when you build the graph, how do you capture those dependencies? How do you I guess how do you draw the edges? I
Mm-hmm.
guess is the proper term.
Yeah, so I guess uh, a lot of it is based off of domain knowledge of like how we've been.
Mm-hmm.
I guess when it so we will do things like what I said with that example with Okta users being able to assume AWS roles. Well, that's a scenario that's well supported by Okta, and then so we know. All right, well, we know that. I mean, I would like to know as a platform owner or on the security team, I would like to know what are all of the people that are able to assume a given role in AWS, and then can I have visibility on that? Can I answer those questions?
Mm-hmm.
Uh, and then, or I could want to answer the question like, if somebody gains or loses access, can I watch that happen over time? And then, so can I answer those questions with the graph that I'm maintaining with cartography? So a well-oiled cartography installation is very powerful for like basically to answer your question. It's like if you can think about something where I have an entity and I want to know how it interacts with another, then we've built a set of plugin infrastructure and then modules that let you be able to express that very in a straightforward way.
So that's the heavy lifting you do up front before the actual data collection happens, right? Like it just doesn't go out and collects data. It's like there's a lot of work on your end that goes into that data collection to capture those dependencies.
It's a little bit of both.
Uh-huh.
Yeah, it's a little bit of both. So like the every module will have like this process of getting it and then transforming it and massaging it into a format that Neo4j will be happy with,
Mm-hmm.
and then loading it. And then so the loading phase, this is the where the so-called secret sauce is, right? This is where the real value of cartography is, where you have um, our entire open source community has come in and like given their own view about how they build their own knowledge graph of
Mm-hmm.
how they think about and reason about these dependencies and how you would want to relay those relationships between different assets.
Mm-hmm. Mm-hmm. And as a new user, how much how much knowledge do I need to have about the original data sources versus knowing cartography schema? What's the difference there?
I would say that we've tried to be as faithful to the original as possible, but for those gaps, I mean, it's all at some point a human had to make those things, and then
Mm-hmm.
so like there's to capture those things. We have one of the early decisions we did in open source I'm very happy with is that we started from the beginning to enforce that everything had to be documented, like the schema had to be documented, that because these things can, well, and it has grown pretty big, and we've struggled with some of that growth, but uh, to capture all of that knowledge as a newcomer to the project, I would say that we've put a lot of effort into documentation, and there's
Mm-hmm.
parts that uh, need improvement, obviously, with any open source project, but we've tried to stay as complete and thorough as possible there.
Mm-hmm. Mm-hmm. And what were some unexpected insights that you guys got once you've been, developing,
Hmm.
I mean, more sources, right? More connections. What were some of the things where you said, like, "Holy cow! Like this is amazing." There must have been something like that.
I guess like there's certain situations where you find, what is this account that I don't know about? Why do I have an asset that trusts it? How do I find out more about that?
Mm.
Or why do I have so many people that can become admin? Why do that kind of thing? There's all sorts of those. Like I think that what cartography, one of my favorite things to do with cartography is you can use this graph approach to highlight something that is a systemic risk to your organization, and then you can uh, build, I guess, you can build different methods to show how you are burning that problem down. So
Mm. Okay.
if your problem is like uh, over over permissioned resources or too many people have access to this one thing, well, you can. We've built numerous different dashboarding tools. We've blogged about how we've done that to show, all right, well, this is the number of admins you have at this point, but then it's going down at this other point in time.
Got it. And who are the consumers of this information? There's obviously you yourself, but how do you distribute this knowledge? Who are the people that are consuming this data, and how do they consume it? What's sort of the interface?
Yeah, I think that couple. I guess you would have so-called power users that are
Mm-hmm.
what you call querying the graph directly, and so they know the query language they have deep knowledge of the query language, and then I'm not a front end web dev guy, so unfortunately we don't have like a web front end or anything like that. It's been hard to prioritize something
Mm-hmm.
like that, but we've been able to work around that for a very long time by doing things like having an ETL job that essentially queries the Neo4j graph database and then extracts that to a Hive table. And then so once you have that in Hive, then you can do all sorts of fun stuff like put it on Mode dashboard and you get your report that way.
Interesting. Okay. Okay. So there's the transformation to something more rows and columns based. If you
Yes.
use classic analytics, interesting. Yeah.
Yes.
But
I would say, yeah, go
yeah.
ahead.
No, no, no. Go ahead.
No, I was just gonna say that like the transformation from graph to table is trivial, and then but the other way around from what we're doing with like uh, taking the like AWS API data, whatever API data, and then like putting it into graph form. That's harder. That takes time, and it's easy to do wrong. There's all sorts of fiddly things and ways to make that make mistakes with it, and create a representation that is not correct or has bugs and things like that.
Mm-hmm.
Um, I am interested in seeing the things like with like what large language models and how they will change this up. I think that uh, but until that comes, I think that having a human perspective on this is what how I imagine these assets to be related to each other, and then representing that in a knowledge graph, that's still pretty fun.
And it's very powerful. Yeah. And I'm trying to think about, you mentioned something around, the transformation from the graph to a table is trivial, but the other way around, not as much. Can you talk about that a little bit more? Like what, like, and I
Mm-hmm.
mean, I share that view, right? But because the classic ETL ecosystem is around rows and tables, right? And
Mm-hmm.
getting that data just even in rows and tables is super valuable. But talk a little bit about like why the graph? Why is that valuable at that point?
The the reason the power of a graph is that it lets you explore, it lets you see many to many relationships in a very easy way. It lets you express those things in a way that if you had it in a table, you would have just, it would become intractable. Like you would have like 8 foreign key relationships. You'd be doing all kinds of joins all over the place, and
Mm-hmm.
then it's just difficult to reason about. um Obviously, like but graph isn't for everything though, and then eventually, like if you're building, say, a state machine, like what I mentioned with like the vulnerability management logic, that you'll eventually want it to be like some sort of ledger that says that, oh yeah, with a checkbox that says, oh, this issue can be closed or not. So you will want a
Mm-hmm.
table at some point, but your analysis layer with a graph, that is powerful.
Yeah.
And that is powerful in ways that a table can't do, because the graph can tell you things like what is the greatest ancestor where this issue was introduced at. So like from which parent image was this problem introduced at, and then so I need to go all the way up there. Or other scenarios like uh, this one is something I'm very excited about, like as somebody with experience in offensive security, where say I get remote code execution on an internet exposed compute instance, and then I'm able to get credentials off of that. What is the blast radius of this initial exposure? How many hops can I go, and then how much of the infrastructure is exposed due to this initial compromise?
Mm-hmm. Mm-hmm. Yeah, the blast radius. I mean, that that term always comes up with a graph. Uh, and you talked about this having a human perspective on how these different assets relate to each other.
Mm-hmm.
When you built it and you went to your, I'm going to call them customers, did you encounter, and I'm asking, is it kind of a leading question because I have that experience sometimes where people say there's no way. There's no way that anything is wrong, or it's like, no, it's all taken care of because we, whatever, we use the Kubernetes API, we use Terraform, whatever, we have drift detection. Did you have moments where you could say to someone, no, 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 hold on,
Mm.
take a look? Did that ever, do you know what I mean? Like, did that ever happen?
Yeah. Like, oh, there's no way that there's no way that we're exposed to blah blah blah. There's no way that that I have way too many things running. Um, and so like there were, I would say this happens to me about like at least once a month.
Yeah.
Where you, and then I love being able to go and find and shine a light underneath the rock, so to speak, and then so being able to see things like, well, especially because to do this with to do a lot of these things with, say, the normal web portal, if you were to go into GCP yourself, if you were to go into AWS console yourself, you'd be clicking through so many menus, and then like that's no fun. And then but
Yeah.
when I'm able to show like a view, I'm like, yeah, this is your view of everything you have by all account, by every single thing. Well, that's, oh well, you can't really deny that. And then the best part is when you're able to grab a little bit of that data and then validate it for real okay, yeah, right. It's your graph is like actually accurate up to this point. So yeah,
And then you turn them into believers, right?
that's the hope.
Yeah. Yeah.
And I guess one of the other things too, since we were talking about a little bit about analysis, we're also able to do some very powerful things to reason about permission relationships. Like say in I mentioned a little bit before about how Bloodhound was focused on Active Directory, and then, well, when it comes to like the cloud and permission relationships, AWS IAM is complicated in itself too. Where if to answer the question of is this given principal having permission to this specific resource, that's very, very difficult to answer in certain cases. And then reasoning about that, uh, good luck. There's nothing like in Windows. Like if you were to go click on a folder in a domain environment, you can right click on that, hit the security tab, and say view effective permissions. And these are all the people that have access to this one entity.
Hmm. Yeah.
AWS doesn't really have that unless you pay for, I forget what that product is called. There's a number of different products that you have to pay for as add-ons. But what we're able to do with cartography, though, is that we evaluate all of the IAM policies that are attached to a given principal and evaluate that against all of the resources that are available in your account, and then draw relationships that say
Hmm.
this identity can read or can write this bucket. And then, you know, having it all exposed this way, if we were to do this in tables, I think it would have taken a lot more time.
Oh yeah. Yeah, yeah, most definitely. Yeah. And what are some of how do you build out your use cases? Can you share some of the major, like, there's got to be some sort of library of use cases, writing queries, you store them somewhere, you run them on a schedule. Can you talk about that a little bit, the use cases?
I would say that the main way to think of use cases would be, I mean, when I think graph, I think question and answer service, because you put a lot of data in there and you want to see how they're connected, and then having them, I want to see, uh, can I use this map that I have to get me something that I don't know? And then how are those
Hmm.
things connected? And then if the graph isn't able to tell that to me, if the graph isn't able to answer a question for me, I have to ask myself, well, why is it? Do we have a gap in support? Do we have a correctness issue? Do we have something else going on there? Is the graph the right answer for this problem? In some cases, no, that's not the case. Like there's like scenarios where this approach, where using the graph like does not work out. Like example, like if you want to do it for uh, near real time, if that truly is a need, don't use this approach because this is all like a heavy batch processing. But for a lot of cases, if you need to answer a question and if you don't need that question to be like within the second, then this is more than good enough.
Yeah.
Um, I would say that that's the general approach that I would go for finding scenarios with this. And that's something that has been, I would think about it like a Swiss Army knife, that in a lot of cases, it's been my experience where the graph was able to get me maybe about 85% of a given problem. And the last 15% needed me to code up a couple of other things. And then it would quickly get me there to the 100%.
Right, right. But I think you just laid out a really important concept, because in the world of security and monitoring and APM, it's always about real time or near real time, right? And for good reasons, right? If you have production
Mm-hmm.
issues, you want to know immediately, right? But this approach, I want to call it an analytical approach to infrastructure, seems to be fairly new, and the whole notion of extracting data, putting into a single place for analysis, and then sort of use it as a foundational layer for long-term improvements, not to react real time. That doesn't seem to have taken hold with a lot of people so far. I call it, we're peak XOps. There's a DevOps, DevSecOps, FinOps, well, you name it, right? There's like no shortage of XOps tools, and and I feel like this is new. And when you do, like, I mean, you do a lot of community work too around cryptography. Is that something is that a point of view that you would share, that it's now time for an analytical approach to infrastructure data?
Hmm. I don't know if I would say something I don't know if I would be confident enough to say something that I guess um, what's the word, bold maybe. I think that there's a time and place for all of those different
Hmm.
approaches to go look at things. Uh, I would say that in my experiences in InfoSec, I can't imagine ever going back to a world where I don't have a capability like cartography, where I don't have an analytics capability of being able to say, what, given this asset, what are the things related to it? And then being able to answer that question very quickly. And
Hmm.
if I don't have that, I think that I feel like I'm totally in the dark. Um,
Yeah.
and like there's right tool for the job kind of thing, and then cartography is like in a lot of situations it can get you basically near answering like all the questions that you might need. Yeah.
Yeah. Yeah. And I think also the data collection approach is different, right? Lots of these other tools require installation of an agent, right? And that means there's a proprietary perspective. There's a different data format. So maybe so we've covered a lot of ground in terms of like, okay, this is how we get the data in, this is how we collect it, this is how it's laid out, and then can we talk a little bit more around now extracting insights
Mm.
from the data? You mentioned how power users or have to learn a certain, I think it's Neo4j Cipher. What is it called?
Hmm.
Cipher query language? Yeah. And then
Yeah.
remediation maybe is the next step. So can we talk a little about extracting data? Who are the people, power users, maybe not so many power users, and how do you turn it into something actionable? How do you take action?
Yeah. Let me see. So the first examples that I'll kind of go a little bit more in depth about the container example before,
Hmm.
where the whole point of building out a system like that was to create a list of actionable things that people needed to do to fix the vulnerabilities on their container images. So uh, again, you'll scan a service image, you'll calculate the dependency tree graph of like all of those issues, and then you will say that the payment service has a number of issues, and these are the issues that it inherited. These are the issues that affect it right now. All right, for every single one of those things, let's build automation around that sends a ticket to Jira that says, all right, well, payment service needs to resolve CVEs 1, 2, and 3, and it's present in these packages. And I'm going to go and assign that to the on-call for the payment service. And then we are able to do all that and correlate all of those things because it's in the knowledge graph also. Payment service has an entry in the graph, then that's synced up and tied together with our PagerDuty data. So we know who is on call at that given time, and we know who's the owner, and we have attribution. We're able to tag them specifically in the ticket, and they're able to get that list of specific things. Not only do we tell them that, we also tie it to a specific GitHub PR. So we'll tell them that this is the GitHub PR that you need to merge in order for this set of issues to go away. And in some cases, we're not able to give a PR, but we're able to give, all right, well, this is the specific library that is affected. So you might want to give a deeper look at that. And if you need help, reach out on this Slack channel, come talk to us. Um, that's sort of the general flow about being able to like ask the graph a question, correlate it with lots of other things, put all that context together in one place in that ticket, and then uh, send it out, and then put a bow on it basically. And then at the
Nice.
end of all of it, the next part is reconciliation, because it's a really awful user experience to just throw 10,000 different tickets at people, and
Yeah.
then kind of, what are you going to do? Like, you're going to expect them to go through every single one of those things and hit close? Like, how do you know whether something, how do you hold people accountable for that kind of thing? And then so what we do is that, well, we maintain that state in the graph where the next scan will come back and then say, it'll be able to tell, oh, well, these are the issues that were remediated since last time. And this, this issue, which was tied to this service, no longer exists. And then, so therefore it was connected to the Jira issue that we filed. And so therefore the linked Jira issue, we identify that as being able to be closed. So we'll go and close and say the issue has been resolved. thank you for helping us out. And then we're able to track it that way.
Okay, so cartography actually understands the delta between two graphs. I assume you take a snapshot, right? And then you're able to compare the two snapshots, understand the delta correlated with, in this case, a ticket, and you can say thumbs up, thumbs down, resolved, not resolved.
Well, let me see. So to explain that a little bit, cartography is all about point in time data. So it will only maintain the current timestamp of like all of your environment. Everything else, so in this case, like if a given scan has like issues, has all those issues, but the next scan has none of them, then the graph will show that it has no issues. And so it's kind of up to a separate system. It's up to some separate job to do that reconciliation, because cartography just shows like the view of like what the world looks like, and then we have a separate set of code that will be that sort of issue management code, and then do that reconciliation, and then say that all those issues cartography has cleaned them up, and then so all right, well, now I know that they can be closed.
Okay, so that's a different piece of code. That's a different. You called
Yes.
it issue man. Oh, okay,
Yes.
and that's not part of cartography.
It acts on the graph, but it is. I would not consider that to be part of the code that updates the graph. If that makes sense. Like you'll have a sort of a relationship where it's like you're building your map, and you have something else that consumes from the map, and then makes a decision based off of what it sees.
Which is so effectively use data out of cartography as an input to another piece of code that then acts based on that data, correct?
Yeah. You can use this analytical thing as an automation platform, basically.
Yeah. And so, and at that point, you essentially have two pieces of the equation, right? You have an analytics part that extracts the data and maybe surfaces certain policies and rules, or vulnerabilities, and then you take that as an input into the second piece, which is the automation or the governance piece, whatever you want to call it, and that now allows me to take action, perform an update, but also do the reconciliation between these two, so that I don't get completely blown over by a gazillion tickets in Jira.
Yep, that's the idea. I think that probably not. Yeah, again, like one of the things that we said to ourselves when we were starting this is that's just not an acceptable user experience with the level of, with like the number of what we got, 1,000 different services, and if you think about like every single month, if they're going to get 100 tickets each, no.
Yeah. So is there something? If you told your users tomorrow's like, hey, sorry, we can't use cartography anymore, they would probably stage a revolution at that point.
I don't know, actually. I wonder. Like, I think that it does its job behind the scenes. I think that it's not super visible. Again, I think that the reason for that is that, like we talked about earlier, I can talk about like how Cypher has like a really long, a big learning curve and things like that. But at the same time, you don't want your users, if even if it's SQL, you don't want your users to be running raw SQL anyway. So
right.
So SQL, your database on the back end, it'll always be behind the scenes. It's just that it's the applications you build on top of that database, how you consume it. And I've just sort of been in the unfortunate position of never having written front end code.
So to really get to realize the full power of cartography, do I need to become a power user? Like, what do I need to learn? Do I need to learn Neo4j's Cypher language, or there's always different sets of users, right? What do you see? What type of users do you see?
What types of users? I guess to get the most out of it, I think that it is worth learning the query language, and then toward that end, we have a number of different samples and different things that you can, I guess, cartography flavored samples that you can use that are tailored to our specific schema.
Understood. Yeah. Okay. And where else is cartography in use now? What other companies are using it? And let's talk about the community a little bit. I
Mhm.
know you have community meetups and everything. Like, let's talk about the community building aspect of cartography.
Yeah, I think that the I guess one of the most exciting things about having this out in open source is having the opportunity to sort of meet all kinds of people from around the world, and then I think that we have. But then on the other hand, like I'll say this first, like if you are out there, please come and say hi and please reach out.
Yeah.
I would love to learn more about who is using the tool, how you are using the tool. I'm giving a couple of ideas about how we use it at Lyft. Is there something that I'm missing? Is there some value or scenario that you're seeing that I'm not seeing? That's what
Hmm.
I absolutely want to learn about. But of the people that have reached out to us, we have users from MessageBird, from Thought Machine. I believe that they are based in Europe.
Hmm.
A couple of other. There's a good number of security SaaS companies that use us,
Ah,
and then I think it's uh, so that's been pretty fun. That's been pretty interesting. And then I think everybody else, like, yeah, again, like I just really want to meet you. We want to find out more about what those use cases are.
yeah, yeah. And
That's
we'll
the
link.
hard part about open source, right? Like you put the code out there, but then you don't necessarily know who is pulling it. You can see who forks it, but then you don't really see how it's being deployed or things like that. So,
Yeah,
yeah,
yeah, yeah. And you don't know how they're using it at that point. Yeah.
right,
And in the episode, we'll link to the repo and your LinkedIn profile. And we've done a lot of telling. Maybe it's time to do a little showing. Like, can we move from the?
sure.
Can you maybe share your screen, give us a quick demo, show us around, like what's worthwhile seeing? Maybe some aha moment. I always like to see an aha moment. Like, what's the first time when I use it? It's like, oh, now I get it.
Sure. Let me
Hmm.
just go and get my thing set up. So I have a set of demos to play with. I have a test database. So you can, so this is like assume that you have
Hmm.
set everything up and then you have run everything. And then I guess the first scenario that I would like to show. So this is what the Cypher query language kind of looks like. And
Hmm.
so this is the scenario that we kind of talked a little bit earlier where do I have a compute instance that is open to the internet that can that has a trust relationship with an AWS role. So if I'm on the instance, there is a something called an IAM instance profile, which means that once you get there, you are able to dump creds on the box and then
Hmm.
assume the role that is associated with that instance. So what role is associated there and what trust relationships are attached to that initial foothold that you get, and how many hops does it take to get to a bucket that is your target. So in this case, this would be my bucket 123.
Hmm.
So if I run that, let me just expand this a little bit. Does it let me do that? Yeah, okay. So if I run that, I've got my bucket over here, and then kind of working backwards, we can see that this is the bucket. This is one of the roles. So there's a number of different roles that have read access to that bucket. And you see sort of this chain of this path of there's a number of different attack avenues that I might want to look at if I'm if I'm an offensive attacker. So I can get like one of these instances, assume this role, and then kind of hop over
Hmm.
a couple of times to get to my target. And then if I am, I can also write some. I can also probably refine this query to make it order it by like, oh, which is the shortest path to get there and things like that. But reason why I'm sharing this particular query is this is sort of the genesis, the original motivation behind building this tool in the first place, being able to find these attack paths and then express them um, in a visual way, and being able to I mean that whole overused bit about attackers thinking graphs and whatnot. So
Hmm.
this is the first scenario I wanted to share.
It's very
The
consumable in terms of information, right? It's like it shows me all the complexity, but in a simple graph. Like I can, otherwise there's no way I could get from one asset to another one, right? It's just not
right.
possible.
Right, and then
Hmm.
there's a couple of things going on here too, where it's like, okay, well, we keep that map of the trust relationships, but then this is what I was talking about earlier, where this can read relationship. This was developed by my colleague Andrew, where what we're doing is we evaluate all of the policies that are attached to this role against all the possible resources, and then after that computation, we are able to draw that edge, so that can read
Mm.
edge. So that's that offline permissions
Hmm.
evaluation.
Hmm.
So
Do you
yep,
have a
go ahead.
sorry to interrupt. Do you have a concept of different edges? Is it like logical dependencies edges? You said like can read edge. Uh, does that concept exist in cartography?
Yeah. So with we actually have we blogged about it here. So this
Mm.
let me see, can read. Yeah. So we blogged about it in the post is called "I am whatever you say I am," and we did we go into like how this thing is complete is computed.
Yeah. Okay. Cool. I'm gonna link. We'll include a link to the episode,
Awesome.
to that blog post. Yeah.
Yeah. And then I'll go on to sort of the next scenario that I have. This is something that I was working on just this week. So we're going to shift gears a little bit from, so that's the attacker mindset. And so this is more about, I am on the security team. This is my kind of my infra mindset. One problem that I think a lot of people at cloud native companies are facing is how can I consolidate all of my accesses? If I have a lot of roles, how can I is it possible for me to delete one? And if I delete one or if I remove an access, are there other ways for my users to still get what they need? So in this
Hmm.
case, we're looking for, again, my bucket 123. Are there principles, are there AWS principles that are not admin that still, and I want to kind of see also, are any of them assumable, human assumable using Okta?
Hmm.
And so in this example, we have my bucket, and then we have a number of different roles that are able to read and write to it. However, only one of them is actually human assumable because this role has a um, Okta group. So it has an Okta user that is a member of this Okta group. They will be able to assume this AWS role, and that is a feature of Okta. And then so if for whatever reason, today, like I've been working on this week where I would have somebody on the infra team come and say, "Hey, I lost access to this bucket." I can go and ask this question. Well, okay, what are other ways for you to get access? Would it make sense to include yourself here? And if not, we should look into creating another one for you that has that minimum set of permissions to get you there.
Hmm.
So this sort of like helping you reason about your infrastructure, come up with a way to help out with least privilege principle.
Hmm. Fascinating. Yeah. Yeah. And so that's one use case. And and this is Neo4j, what we're looking
Yes,
at, right? Yeah.
yes,
Okay.
yes. This
Got it.
this is the UI that is presented by Neo4j.
Hmm.
Um, I do have one more scenario that I wanted to show, kind of
Let's do
talking
it.
about the. Let's see. Let me do this. All right. So a lot. This kind of goes into how we were talking about graph versus table,
Hmm.
and where I think a lot of infra teams want to know what is my inventory of all of the assets running on my account, and then how can I group them up by Kubernetes cluster, ASG, what are the tags on them, what's the storage attached to them, just give me that. And then so if I look at it at a graph, it's sure, I mean, it's cool and all, but it's incomprehensible. I'm looking at this, I'm like, yeah, cool, I got my account over here. This is a ASG. This is a Kubernetes cluster, and then I got my number of instances. Sure, but you know, taking graph and then going, let's let's go to table now. So like what I want to do is what I'm able to do is if I put this here, if I just say, okay, from every single one of these nodes, I want to sort of get those attributes and show it to me in a table view. And then it'll crunch through and then it'll just show me, okay, well, here's your report basically,
Mm.
where this is my 10,000 different assets. Here they are grouped up by image ID, type, launch date, account name, environment, and all sorts of other metadata that I have. In certain cases, some of them have tags, some of them don't. And then what we've done is what you can do is that, like I said, cartography only shows point in time data.
Mm.
So this is only like at one given point in time, but you can take do an ETL job or some other thing where you will take this data, load it into Hive, and then you will have that over time data that you can expose in some other dashboard for management and other purposes, all without
Oh,
needing to write front end code.
yeah. Okay, so that's how you get time series data. Okay.
Yeah.
Has I just remember how Lyft at least in the past was a Redshift user, Amazon Redshift. I don't know if you've migrated. I mean, you just said Hive, but um, do you run analytics on this data somewhere else? I mean, obviously Hive, you just said. Like, is there anything
Mm-hmm.
else? I don't know, Snowflake, Redshift, BigQuery.
I am not a data engineer. I don't. I just know some of those words.
Okay.
Yeah.
Okay. Got it. Okay. But matter of fact is that you're exporting this on a schedule,
Yes.
and that's how you can start creating a timeline. Um,
Yes.
got it. Yeah. Because cartography is point in time. Okay, great. Now, and like 4 years in. You're 4 years in
4 years
developing.
in.
Uh,
Yep.
Amazing. Congrats. Now, with these 4 years under your belt, if today you would let's assume you had to rebuild cartography. Let's just say there's a need for all these use cases you've built. What would you do differently? Would you do it the same way over again? Like with all the lessons
Oh,
learned, what would be different?
I think that we would introduce abstractions earlier. I think that
Mm,
every software project has uh, there's a spectrum, right? Like you either you introduce a bunch of abstractions early on, and but when I mean abstraction, I mean like because right now the code is written in a way that you're essentially copy pasting different modules, and then it's very error prone to write these queries to load data to the graph, and they're handwritten essentially. I would we have worked on to put a lot of work into building our own data model around that, and then making it so that new developers don't need to worry about those fiddly things
hmm
like getting the particular like IDs correct or whatever. Um, if we could do it again, I think that I would do that earlier so that kind of get more people able to contribute faster, and then make it so that we're able to grow faster in terms of like the test coverage, and make it so that we can have that confidence that like the goal that we've always been trying to have is like make it so that if a test passes, then if all tests pass, we should be able to accept your code. Like that is the dream state to be in.
Yeah.
In a lot of cases, this hasn't been the case for us, but that's sort of been our dream. And then
Got
so
it.
going back in time, like I think that we would try to introduce that earlier, try to prioritize that a little bit earlier. What other things? I think technology choice. I mean, graph. It was always going to be graph. I think that we made a conscious decision to keep it easy to adopt without being taking heavy dependency on like a specific architecture. Like I said, like it's kind of keep it simple, like make it like a up to the deployer how complicated you want to make this to be.
hmm
Um, and yeah, I think that that would be the big one, like having making it trying to prioritize that, let it so that it's easy to contribute and easy to accept, easy to say yes. That's it in
Yeah.
a nutshell. Yeah.
Yeah. Yeah. Great, but no major fundamental changes, as in you said. You would still go with a graph database, and that's, oh my God, had I known this, we would have done this.
Hmm,
Yeah,
correct. I
yeah.
think that also, knowing what I know now, I think that I would probably also maybe be a little bit more clear and upfront about the things about what the tool is and what it isn't. Um,
Mm-hmm.
like saying, making that conscious decision upfront that this is point in time only. This is what we do. We don't. We will not do historical. You want to do historical, you will do something else. Uh, because I think that a big part, like it's really important for the identity of a tool is defined not only by what it is, but also by what it isn't. And then so,
Yeah,
like in this case, it's like we're not historical, we are not real time. However, we are analytical and we cross correlate, and you can get a lot out of that, and you can augment the shortcomings by having separate systems make up for that.
yeah, yeah. Taking notes here for the summary, because I think you're listing some amazing insights here. Uh, eh, what the one final, I have so many more questions, but we have limited time. Um, your queries, is that what is the type of collaboration around those queries? Because there's all sorts of intelligence in those queries to detect vulnerabilities, misconfigurations. Um, is there like a common repository where, like, how do you collaborate on that, and how do you make sure that that knowledge gets dissipated throughout the organization and other users of cartography?
Mm-hmm. I think that for anything sufficiently complicated, we try to have like a one pager spec about like how we want to model something, and then we solicit input from the
Mm-hmm.
community. We've done a number of those open public documents, such as like this is how we want to evaluate those permission relationships, and then we've shared those widely, and then so we get community feedback on that. Um, yeah, that's what I would say. And then we, once the decision is made and once it's all implemented, we try to document it in the schema. But there's also
Mm-hmm.
simple cases where it's like fairly uncontroversial, where it's just like, yeah, well, this belongs in an AWS account, so of course I'm going to draw an edge there. And then it's very powerful where you have like one type connected to another type, to another type, to another type. It's like, oh, just then you kind of build on top of that, and then there you go.
Yeah, yeah, makes sense. Okay. So, if people want to work with cartography and if they want to communicate with you, what's the best way to reach you?
We do have a Slack channel.
Ah,
Just go to github.com/lift/cartography and come say hi in Slack.
awesome. Uh, Alex, anything we didn't cover that we should cover? I think we covered a lot, but this is pretty amazing. Anything I forgot to ask that I should have asked?
No, I think that it's been fun. Thank you very much for having me.
This was super valuable. I love it. So, Alex, thank you very much. This was an amazing episode, and I say that with every episode. It's like we got to do a follow up 6 months, 9 months down the road. So this was exciting. Thank you so much, Alex Chantavy from Lyft. Stay on, Alex.